as I said, is data warehousing. So these are. Everybody comes.
The lecture was.
No problem. No problem. Okay. So we are basically doing, as I told you, we have two parts, right? Data management, organization, and then data use. So this chapter is about data organization, management, collection, right? So this is the second part, first part. And we are talking about something called data warehousing, which you may have, at least part of it, you have covered that in DBMS2, if I understand correctly. So we are just continuing on that. And in this chapter, we will try to understand what data warehouses are, what are their characteristics, something called data marts. Maybe you're already aware of some of these terms, but we will go into some other details like their architecture and some other things. Inshallah, as we go along, if you have seen something, we'll go quicker on that. If you haven't seen it, inshallah, we'll try to spend more time on it. So, what is a data warehouse? As maybe you already know, it's a repository like a database, right?
It's continuous place storing data historically.
Yeah, you store historical data, right?
Yeah.
But even in database you do that, but there is a small difference, right? So we'll try to see what those are. Where relational data are specially organized, meaning that you might be storing data into relational databases. So I hope you still remember relational databases. No, 309. Whatever you studied there, it's called relational database. You remember tables, relationships, primary keys, foreign keys?
Yeah.
Base table.
Yeah.
The base tables, not the view.
Yes. So all those are called relational databases, right? Relational because you do not have like one big table in which you put the data. You organize your data into tables that are linked, related to each other, right? So relational, you take those relational data and then you take this data and you reorganize them in a special form. So this is one thing. Another feature which is important is that you take this data but you clean it. What does cleaning mean? Cleaning meaning that you take out unnecessary things, incorrect things. So you do some processing on the data, right? So cleaning is another important aspect, and then you put them in a standardized form that is focused not on efficiency but that are focused on effectiveness. So I mentioned that yesterday, but I'll try to explain it again. My question is, in 309, when you were studying that course, why there was an argument to put data in different tables? Why was an argument like that? Do you remember? Anybody remember that?
So it doesn't overlap.
Repetition, right?
Yes.
The same data has to be repeated again and again in the same column, right? Integrity, redundancy,
Isolation.
error, right? Many of those things. Which means that you have to do a lot of tasks. Which means that for the sake of efficiency, you try to minimize your work, writing the same data and again, right? So it was based on efficiency, but here efficiency is not your concern because people are not using on daily basis and minute basis and hourly basis, so those databases are heavily used. But data warehouses are used by few people who are doing analysis and they are not concerned with the repetition of data being a problem, right? So if I give you tables like these and I give you this data for analysis, you'll say I don't want it like that. I want it like in a single Excel table. You understand that? So you want to rearrange it in a form that is more, what you call more effective, rather than more efficient. Efficiency means you're looking for space, volume, and speed and many other things. So standardized form meaning that you bring it into a form that is suitable to you. So so it means what? So data warehouse is something which is a collection of integrated, subject-oriented database designed to support DSS function. Excuse me, we need to spend time on it. Integrated simply meaning that when I'm looking for this data might be in different places. Integration meaning simply to put things together, right? So that's why database, data warehouse without the concept of integration is meaningless. Majority of the time you have to collect data and put them together. Secondly, data warehouse is designed to do what? To support your decisions. And decisions cannot be aimless. You all agree? I have to take a decision on something. I have to take a decision of how much am I going to order the raw material, right? Or how much the loan I have to take. One is financial decision, the other is supply chain decision, right? Or how many people do I have to hire, right? So do you see that there is a purpose, and that purpose should identify what subject you're looking at. So this data warehouse might be serving supply chain decisions. These data warehouse might be supporting your financial decisions. These data warehouse might be supporting your HR or management decision. Do you understand that? So subject orientation is also very important, but it might not be the case in your relational databases where it's data driven, not subject driven. Do you agree with that? When you're designing a database, are you thinking about data or are you thinking about the subject? So for example, if you're thinking about customer, right? Age, gender, data, things are driven by data, not by I have to take purchasing decision. Do you agree with that, right? So this is the difference. Subject oriented to support particular decisions. And moreover, one of the things that usually come that people generally do not think about is that these data warehouses are what we call non-volatile. So what is the meaning of the word volatile here? You know the meaning of the word volatile? Volatile is something that is quickly, very quickly changing. Something that changes very frequently. Okay? So in databases, new transactions are happening, so the actual database is changing frequently, right? Do you all agree with that? But data warehouses, when I'm taking a decision, I want my data to be consistent. So because we are looking at historical data, right? So then if the data is changing, how can I take decision, because the data form is constantly changing, right? So one of the things that data warehouse, it is important in data warehouses that these are number one, non-volatile. Secondly, they are time stamped, meaning that relevant to a particular moment in time. So this is again a very important feature. So when you are recording a customer name, are you like putting it like when, maybe you are putting that, but your main concern is like what's happening today, what's happening tomorrow, what's happening the next day and so on, right? But when it comes to data warehouses, you need to know it has to be time based. For example, average per day, average per month, average per week, and then you say week 1, week 2, week 3, week 4, week 5, or day 1, day 2, day 3, day 4, right? So it is always time driven. Why? Because decisions are time driven. Now imagine that you have to order raw material and you're running a grocery store. I keep giving the example of grocery stores. Now Ramadan is coming, right? So you can see that your demand is time dependent, right? Ramadan, certain product say demand goes up, right? And then after that, maybe those demand will go down. How do you see that? You see that only when you're seeing it on a timeline. So time is also another feature. So let's just recap. So what are the important things in data warehouses? Integrated, must be driven by a purpose, a subject. To support those decisions, should be stable, should not be randomly or very quickly changing. And then you must link your data with time, because you need to see this data over time. This is just maybe an off topic. We'll come back to it, to the same discussion that we are doing. But just some history was mentioned, which is not just out of interest if you want to see. Things started long time ago in the 1970s, where you had like mainframes, and people started to record data like what you do these days in Excel. And then people started to try to get some reports out of it. Then people very quickly realized not the best way to do it. Then in 80s you started to see relational databases, what you see in your DBMS one. And then computers started to appear, those PCs, and some mini computers. And then it was really in 1990s that people started to think about maybe data is still not in the best form that we need to make decisions. So data warehousing started to appear. 2000s BI, use of data started to appear, not just collection of the data. And then these days you're talking about those advanced analytics. So I've already talked a lot, so I'm not spending time there. So let's just come back to what we were discussing. So what did we discuss on the last slide, the slide before? Databases have to be
Subjected.
so it cannot be data, we just cannot say data warehouse, but you say it has to be like serving the marketing or the HR or the sales or the supply chain, right? Subject oriented. Integrated, I told you that you have to collect data into a single place, so collection is integration. Time variant, time based, all data must be time based. Historical data, not only that, but time based, meaning that if I'm recording my sales, I must have 2023 January, 2023 February, and so it has to be time based. And one of the things we will do later in hopefully in predictive analytics is something called time series analysis that all modern companies are doing, and where they are seeing the pattern over time, and they're trying to capture this pattern over time. I already mentioned non-volatile. Should be stable, the data should not change, especially the one that you already entered. New data can be added for the new period, but the old one should stay the same. Summarized, we have been discussing this since last several classes. Summarized meaning that actual transaction is not important, you want to have it per day, per week, per month, so you summarize, you take sum, you take averages, right? So summarization. What does this mean, not normalized? If you understand normalization, right? You understand normalization from the database. You organize data not in one table but multiple tables, so that we just mentioned that redundancy, and you said what? Integrity and many other things, so they are related, right? Now, because of this, the data is scattered, just to achieve efficiency. But when it comes to analysis, data in so many places is hard to see. You want to put them together in a single table, even if the data is being repeated, because efficiency is not the purpose. So that is why it is non-normalized. In normalization, you don't want repetition of data and all those things, right? What is metadata?
Data about data.
Data about data. So in data warehouse, this plays a very crucial role. Why? Because if you want to identify, for example, the subject, purpose, it's a supply chain data, right? Sales data. How do you know that it's a sales data? Through metadata. You have a meta tag saying that this is the sales data. For what period? 2000 to 2023, right? So all those tags, needs to be there, which will be defining the scope of the data, the type of the data, the purpose of the data, and these are all called, the metadata. By the way, when you'll take the web business application course, they will talk a lot about that, because in Google search and everything, when you have a web page, something you see but something you don't see, and this is called meta tags in web pages, which are not in front, but Google use those meta tags to identify those pages belong to what search terms. Okay, so and then we will talk more about more modern features like web-based data warehouse applications where the front is web-based. But we'll talk more about that in a second. Let's talk about something called data mart. So what is a data mart?
Data mart, like star figures, I think.
Okay.
It's a small place that store certain data to retrieve it.
Okay. Anyone else? So,
Subset of data warehouse.
say again.
Subset of data warehouse.
Yeah, you all are explaining it in the right way, right? So
It's a subset of the database that has a particular subject.
it is even more subject oriented. It needs to be just focused on one
One
department, one subject,
One-
right? So it is a subset, a small data warehouse, but it is part of it. As you said, subset, small, right? So small one. But it may be part of a big data warehouse, or it may not be part of big data warehouse. Now, why do we need to know all about it? Because if you're designing a data warehouse, as a planner, you need to know, do you need data marts? Do you need just only data warehouse? You understand what I'm saying? So we will talk about what is out there, and we will argue that which one is better for what situation. Everybody understand that? So there can be situations where, as you defined, they can be subsets or small data warehouses, but then we can have what you call dependent data marts and independent data marts. And as the word says, dependent meaning that they are part of a data warehouse. Dependent meaning that they are linked to it. Independent meaning that they are like small stores, right? So they can be self-running. So they are like small data warehouses. But we need to know a little bit. We will get to know about few terms, but we need to know more about data mart, especially because in terms of designing a data warehouse in a company, we need a little bit more discussion. So one of the things that you might need during the design is called operational data stores. So are you introduced with the term data stores? Data stores are nothing but, I'll give you an example. So when you have a data in Excel and you wanted to do some work on it, okay? What do you normally do? You start working on the original file, or sometimes what you do is the data is too important, so you just make a copy,
Yes.
right? And use it as a temporary file, right? You process it and then put it where you like. Why do you do that? Because you don't want to touch the original one, maybe it will get damaged. Maybe you do processing and you may have problems with that, right? So data stores, operational data stores are those temporary things. When you're bringing the data in and you are preparing the data, etc., right? You want to have some temporary place which is not affecting the originals. So data stores are what? These are types of databases that are used as interim area for data warehouse. Interim area simply meaning exactly the way I just explained. Interim is always temporary. So when you're moving from one state to another state, you use these operational data stores to process, make sure that you test it, you see that they are correct, then you put it in the place that you like. Okay, so these are like those temporary ones. Oper marts are operational data marts. Honestly, I'm not sure, but maybe this is another subject area where in companies have sales, marketing. So one of them is operations. Maybe most likely it is focusing on that. I think they like to throw terms. So enterprise data warehouse is the bigger one. So we can just call it data warehouse or enterprise-wide data warehouse. Okay. We already talked about metadata, right? We already talked about that. It is data about the data, so that it describes the content of the data warehouse. So we have already talked about that. So let's just talk a little bit more about how things are put together. We know that there's something called data warehouse. We know that there are something called data marts, and we also see that they can be dependent, independent, right? But it's still not making sense. So we have to start putting things together. So we'll do that step by step. So imagine that we just consider data warehouse and see how the whole design works. So you can have a lot of different data sources that you have to consider as a planner. And one of them could be maybe any source. It could be Excel files even, okay? Or it could be some online transaction processing system, as we were discussing last time, right? You go to grocery store and they're scanning. It could be that. What about these? What are these? POS. What is POS?
Planning organizations.
Point of sales,
So what are point of sales?
like supermarket.
So point of sale are when you're purchasing things, their computers are called point of sale units. Even there's your ATM machine, they are called point of sale devices. So it is the data stored at that location. So those devices are called point of sale devices. Okay, so you might be collecting from there.
Like an ATM
ATM card is part of your point of sale. So even the computer, when you go to a retail store, they have this small computer.
Yes.
So when they scan, if this whole unit is called point of sale
Okay.
unit. Okay. So what about ERP?
Enterprise Resource Planning,
So what exactly are the software are you referring to?
SQL.
SAP, Oracle, SAP, right? So do you know how, by the way, ERP works? Is there, or do you want me to explain it?
No, we know it.
So we don't need to go. It's basically an integrated software. Companies used to have bits and pieces. One software for finance, one software for accounting, for supply chain. Those SAP is just bringing you one system, integrated system. So you might be taking data from there. What about legacy system?
Can you re-explain the enterprise resource planning?
Company used to have, you have different functions in company, like finance, right? They have their own software. They used to have their own software, own data. Then accounting may have their own software, their own data. Supply chain have their own, just like this. Marketing, all of them were maintaining their own data and using their own software, right? But this was causing a lot of data problems, data integrity and many things. I need your data and then I have to request you have to send me, the data becomes old and errors, many things, right? So ERP gave the concept that one database for everyone, and then all functions are done through a single software like SAP. So you have SAP financials, you have SAP supply chain, you have SAP marketing, you have SAP accounting and all those things. So it's a single integrated system. So everyone has access to data, in real time, and the data, there's no issue of data integrity and anything. Okay, so this is basically ERP. Legacy systems nowadays have become less of a concern, but legacy systems simply meant old systems like mainframes. I don't know if you're aware of mainframe computers. They used to be big computers.
A workstation.
Not workstation. Mainframe used to be
It's an old system.
not just old system, but you need to know how it works. It used to be one very big computer with a lot of terminals, meaning that those terminals were dumb terminals. They don't have their own CPUs and everything.
Ah.
They're all connected, but they had their own operating system. They
Like
had their own storages, and they were completely incompatible in terms of connecting.
Like a mainframe supercomputer with.
No, supercomputer is a different thing. I will explain supercomputer later.
Like computer lab for
See again.
أنا أعرف اللي هو ويسموه
Nowadays you
سيرفر
don't
أو
have
بي سي
mainframe
كامل
anywhere.
مربوطين
I'm sure you
شاشة
have
زي
not
اللي
seen
تحت
mainframe anywhere.
اللي في قاعة
In
الكمبيوتر
registrar,
عارف
maybe they are
tool
using.
maybe.
Yeah. Maybe they.
On the computer lab.
Maybe they have, but it is very rare to have it in computer labs. Normally, I'll tell you, banks
Okay.
used to have it. Like where you have a central processing unit maybe bigger than this room,
Yes, yes.
right? And then they have just terminals going all across the building. But those systems were not like running on Windows or Mac or anything. They used to have their own operating system, own protocols, everything different. Not even Unix, maybe Unix, old Unix. Because now even mainframes are very rare. Most likely they were running on Unix, maybe. But there used to be even an older operating system, I forgot the name. Maybe the newer ones are using Unix, but the previous one used to have, I completely forgot, but there used to be a very old operating system, I forgot the name. But for example, when I was your age at King Fahd, we used to check email through some of those terminals and it was completely different. So the point is, the problem with legacy systems was that they were completely incompatible to connect to modern systems. And one of the biggest challenges that companies faced, especially last 10-15 years ago, was the whole bank was running on legacy system. Now they have to shift this legacy system to modern powerful computers. So they even had to hire companies who just create softwares that can read from mainframe, convert that, and in a form that new computers can understand, right? So legacy system was a big problem, but it used to be there, maybe still there, but it has become quite less because a lot of companies have already shifted away from mainframes to some big powerful, what you are saying, servers and some other things. But last place we talked about integration. Can you see integration, that we have to collect data from so many sources, right? So we cannot just put them together, because then there are issues. First, we need to select from those data sets what exactly we need. You remember, subject oriented, not everything can be taken. Secondly, once we understand that this is what we need, you have to extract. You may have to run queries, you may have to run some other techniques. What is transform? Transform is your data might be in different forms. One, the sales is recorded in reals, the other sale is recorded in dollars. I need to put them together, I need to transform, I need to have everything in reals, right? So I need to even convert dollars into reals. My measurements are in inches, and in another data set they are in centimeters. I need to do transformation, right? And then integration, and then I have to go through a loading process of putting them in warehouse. Metadata we already talked. Replication is always, as designer of data warehouses, replication is always a very important consideration. But what is that used for? It is simply used for, as we call in modern language, backup. Because company data, always create backups, because data is very precious. If something goes wrong with this thing, what will happen? You will lose your extremely important data, right? So you always have to create what you call data replication. So time by time you create not one data warehouse but two data warehouses, just a copy for that. 2 months back my SSD was gone, but thankfully most of my work is on cloud, so it was fine. But some of my very crucial work, I put that on desktop, because it was like temporary thing. I said I'll finish and then I'll put. And I was like, oh boy, it was a big trouble, because it was like office work I lost it for like 2 months work or something. So we had to go through the whole thing again. I learned even for temporary thing, you need to keep it on cloud.
There is a better solution. You have, if you want to buy something, an adapter, you can just make a backup on other
Hard disk.
on other
It
hard
means
disk.
that I have to do another work, keep copying.
No, not copying. There is an adapter, it works like this.
I know that you can automatically sync.
Yeah.
Yeah, of course. But cloud is another option, right? Cloud is doing exactly the same, and the cloud is the responsibility of the cloud provider, and they are doing it very professionally. So that the cloud data would be most likely safe. Anyways, so and then with data warehouse, what you see here, data marts for
Marketing.
different subjects.
Yes.
Right, so we always need to plan what data marts we need on top of this data warehouse. Again, it does not mean that you must have a marketing data mart or must have an engineering one. Of course, you need to decide as a planner which data marts you need. Whatever is required, you can create one. And then you need to have what we call a front end. Somebody is using this data to use. This is the use side, right? You have to generate reports, data mining, OLAP, and some of the other things. But typically, there is a software in between which is called API. So, what is API? It's called application programming interface. So, normally what happens is that you have started Python, right?
Yes.
So, if you want to use Oracle, you access Oracle database or Microsoft SQL Server, whatever. So the Python cannot do that directly. So there is another software in between. This software is can understand both.
Translator.
Yes. So you basically connect to this API, and through this API you just connect to the other software that you want, and then through this API you're talking to the other software. So API is just like a middleman who understand both software very well. So many times you have to create your APIs. Or APIs are normally already out there, and it has to be used. Now, I'm just jumping, the case study. So let me go there. So if you look at the diagram that I just explained, you can see that they are organized in tiers or levels, right? So 3-tier is what we already saw. By nature, it looks like a three-tier problem. What are those 3 tiers? If you look back, again, if you look at this problem closely, This is like, you know, where you're capturing the data, right? Managing the data and then using the data, right? So same thing is there. 3-tier: acquisition, data warehouse, and then client. Yes.
Is it the same as the three-level architecture?
Say again.
Is it same as the three-level architecture?
Used in what?
Is it same as the
No, it is. But you're where did you? I mean, what is the application that you're referring to? Where is this 3-level architecture used? In
it's not an application. And yeah, it's good. Yeah.
In SQL?
In SQL. Yeah.
The Spark, yeah, Spark.
Spark, yeah. Spark.
Spark is like big data you use in that. But you basically, I understand now what you're saying. I was trying to understand the context. Even there you have like data in the front end and like that, right?
That was 3 levels, I think, of tiers: external and the concept and the internal.
Physical level.
Physical.
Physical
No,
conceptual.
it's another name.
If you're talking about
External user, I think it's
user interface is 1 tier.
user
Yeah.
level, conceptual level, and the external level.
Yeah, it is on the same ground. It is on the same ground where you are, for example, when you talk about databases, the interface is separate than the data storage itself. So same concept. So here you are also saying that you're not putting everything like a single piece. The front end is actually separately developed, kept separate, even running on separate machines. The data warehouse is kept, maintained by a separate. There's separate software for it and separate machines, completely treated separately, right? So and then the data acquisition, even there are different computers, different software, and then they collect and then they store you to the second tier, right? So same concept: acquisition, data warehouse, and client. But normally it works when you have that resources. So sometimes people will try to do. Your company is not big, so they say, let's just acquisition and warehousing. Maybe I'll just use like the same computer, maybe same software doing the acquisition plus warehousing. You understand that? But the decision is mainly driven by your resources. If you're a big company, you have more resources, you're able to buy more computers and everything, then 3-tier is an option. Can you do it 1 tier? Of course, you can just use a single computer doing everything. I'm not sure about software level, maybe you still need to have different tiers, but some people say, it might be possible. So same thing, application database hosted in a single layer and client on another layer, and then you can have these 3 layers separately, okay? So if you look at that, what are the issues are you able to see? What are the issues do you see here? One issue is the architecture that we just saw, right? It should be like I have to put them separately, I have to put them together. Then on top of that, you have to ask questions like these. Data warehousing, which software should I buy? Which data warehousing software do I need? Do I need to use parallel processing to do my data integration and conversion during that? So what does that mean? Do you understand first of all what parallel processing is?
It's multiple processes doing it at the same time.
Okay. If you know your computers, you have, for example, i5, i7, i9, whatever, right? And if you know that they say you have 4 core or 8 core like that written, have you seen that?
Yes.
So what are those? What does that mean?
Chorus, it means lines.
Okay, let me explain. So you need to now understand as an MI student very well the whole concept of parallel processing and your choice of computers. It becomes very, very crucial here, okay? And I will even talk about CPU versus GPU as well, okay? Because I know some of you at least like to play games. So you're looking for NVIDIA GPUs and all those things, right? So in CPU, when you say 4 core or 8 core or something like that, you actually have a physical chip, one chip. If you open the computer, you'll see an i7 processor, for example, okay? But it will say it has 4, let's just say 4 or 8, whatever, some number of cores. So what does that mean? It means I need to explain that thing. Imagine I have 200 copies to grade. Okay, and I give this to him. I say, can you please grade it for me? Now, one way of looking at it is see how efficient and how fast he is to grade, right? So he can be more efficient and maybe he can grade faster than him and so on. That's like comparing one person with another person. So an individual strength of a person, right? I have to lift. You have to lift something and maybe one is more powerful than the other. But another possibility. Now the work is too much. Even if he's very fast, still he will be doing one, second paper, third paper, fourth paper.
You divide it.
I divide it. So instead of one person doing, I ask you to, 4 of you to please grade. You understand that? And all of you in that case will be grading in parallel together. Right? That's called parallel processing. So when you say 4 core, it means that you do not have one worker, but you have actually second worker and you have the third worker and then you have the fourth worker and so on. Modern i9, I see that they are even having 24 cores and all those things.
Yes.
Right? It means what? You want your work to split, divide, and work. So there are 2 ways to work. Make your workers strong, that's one thing. And then you want to divide another one. And the best processors are the ones who are in workers are also strong. And then you're dividing as well. Right? You understand that? Now, this must raise a question to you. Even when you're running your Python code, how many cores are they using? Did you write a program in Python yet?
Yes.
How many cores was it using? I'll tell you, even if you're using i9, still using only one core.
Why?
Because by default, you're not telling, it's your job to tell how you want to distribute your work and sort by how many people. So the program that you have written, you never told that I need my work to be divided and sort by how many people. You can do that in Python, but then you have to explicitly tell, this is my work and I'm going to divide it in so many pieces and how many pieces, how many cores I'm going to use. You understand that? Everybody understand that? You may not be able to do it now because parallel processing is a bit challenging. It is done by more advanced programmers, but the effect is huge. This same computer, I was solving a research problem and it was taking around 2, 3, 4 hours to solve. But then I parallelized it. I did the same thing. I took some time to change my program, split the work. I asked 8 cores to use. And instead of solving in 2 hours, it was solving in like 3-4 minutes. After splitting, and of course there was something called code optimization I did. Right? So you understand, at least now understand the concept of parallel processing?
Yes.
Right? So even if you're having an i9 processor with 29 cores, 24 cores, it's useless unless you actually are doing parallel, explicitly doing parallel. Otherwise, it will not help you much, except that one worker might be more powerful. Okay? So let me just ask you one more thing. Do you know how supercomputer works? It's not directly related, but it can be helpful to understand this discussion. Supercomputers
works with multiple GPUs. It's an AI GPUs like A100, H100 GPUs from NVIDIA, for example.
Supercomputer is a mini system in one place. Like you combine.
Yeah, so it basically uses the same processors,
Yes.
but our computers normally have only one processor, the ones that we buy.
Mm-hmm.
There are workstations and bigger servers which can have not one processor but 2, 3, 4 processors. Supercomputers are specially designed computers which can have 50,000 processors connected to it. Which means that if you have an 8-core i7, right? i7, and then you multiply it with 50,000, you can see how many parallel workers that you can have. But again, even if you run your Python code that you just write on a supercomputer,
Work in one core.
not useful. You're not using those 50,000 workers. They're all sitting sleeping.
They use it for forecasting.
Yeah, but then they split work and you have to use all cores. Then really you get the power of supercomputing. But here is one more important point before I move forward. What if my work is not undividable?
It will take so much time and
You understand? I can only use parallel computing if I can divide my work. If my work is, I cannot cut my work, what can I do? I cannot use except run on a single core. So even in Python programming, when I'm doing Python programming, there are problems which I'm forced to use only single core because the work cannot be divided. Right? So you understand the whole concept behind parallel thing. Why we are mentioning parallel processing here in data warehousing? Because you're taking data from so many sources. You can divide work in terms of cleaning the data, in terms of preparing the data, right? And then you can put them all together, right? So that is why parallel processing can be a very powerful tool. So data migration tools, taking from legacy to your system, they call it data migration tools. So you have to use software that can read from legacy systems or ERP systems and migrate. Data retrieval and analysis tools are basically the use tools, so we can talk more about that later. Web-based is more like relatively recent trends where the client, the analysis is available through browser as well. That's it. Nothing more. It is only that your data client, the analysis where you're getting the reports, you can get it through web client, which means that you need to have a web server as well. Now, I will talk about one more thing, and then we can stop for today. Data marts. I told you that there is still a problem in the way you would like to organize these data marts, so you need to understand. What is the best one? There is no best one. I can say this one is the best one. It depends on your situation. Mm-hmm. You have to decide what works for me based on your arguments, logic, your situation, your company's situation, right? So one of them, the first one at the top, what do you see? The first alternative is called independent data marts. And as the word says, you just have source, you clean the data, you put them together, and you don't have a data warehouse, you directly put them in data marts, directly, small data marts, okay? Mm-hmm. So this might be useful to you, I don't know in what situation, meaning that the departments are working independently, they are not connected to each other, they just wanted to maintain their own data marts. Maybe they don't want to have a centralized data warehouse, then maybe it's a good place to have this arrangement. Okay, everybody understand that? Maybe it doesn't work in Aramco, maybe in small companies where you want to maintain your own data marts. Second one is called, I think you, from the network management course, you may know like bus architecture, and then the star hub and spoke architecture. I don't know.
Buffer?
Yeah.
Buffer?
Not buffer. There are different architectures used in network. So maybe, have you taken a network management course?
Yes, we take it right now.
No, maybe you haven't seen it yet. Okay, so things are arranged in different ways. It can be computer networks, it could be many other things. One way is, there is one, if you go to an airport, there's like one big central area, right? Mm-hmm. Everybody comes here and then you get to sit on your plane in one of those branches. Have you seen those, maybe some of those airports? I don't know, maybe Oman, I went there, they had this way of organizing, maybe Qatar as well. But it is, some of the airports are like that. But some airports are like that, in like a long line, like Jeddah, maybe. They are like, just in a straight line.
You make lines and you go, there is
1, 2, 3, 4, 5, 6.
Yeah.
But this is just the physical form. Conceptually, there's a difference. Here, you have, in computer networks, you have a boss to control at the center. You understand? If I have to go from here to here, I will go through this center. Right? There's a central thing that is controlling everything. Mm-hmm. So I have to go through this to even reach there. But here, everyone is independent. It's like all equal. You know the concept of all equal? Everybody is having the same power, same situation in bus. So they are connected like this. So data marts can be arranged in bus form, or as they say, hub and spoke form. Meaning what? They're all independent, almost data marts, but they are connected to each other. So that if this data marts need something from this one, they can talk directly to that data mart. The key word is I can talk directly to the other data mart. My data mart can access the other data mart directly. Do you understand this thing that is going on? Direct communication between data marts. Okay?
So they are interconnected.
They are all connected, but there is no like a central controlling thing.
There's no barriers.
There are no barriers, direct contact. Okay? In this one, the other one, hub and spoke, you have a normalized relational database in between. So even if there are multiple databases, they actually just talk to this central relational database to get whatever they need. Right? So this relational database is actually like a hub. Right? And then the rest, if they need anything, they actually get not from the other data marts, but from this relational database.
Doctor, you mean, for example, in Amazon there is a mesh hub, you can buy it and this connected to the main router and...
I don't understand what you're saying. Maybe in Amazon, I don't know how it works, but there is like a central thing.
Like an extender. You mean TP-Link, for example? TP-Link connected.
Maybe you have a main router which is like the center.
Like this one. I mean.
Yeah, it can be considered like this. Okay. So, but you understand that this normalized relational database is always at the center. So if they need anything, these individual ones they talk to it. And then finally we have even situations where you get the data but you don't even have a data warehouse. You just have, what does it say? Normalized relational. So it is like a normal database. Maybe in small companies you cannot afford to have a separate data warehouse. But this time, what is the problem here? If you want to get the data, you always have to run SQL queries, because your data might be, you need to get that from different tables, right? So that's like the disadvantage, and you're putting pressure on your database. But maybe you cannot afford to buy another database. So you just live with a single database, right? I mean, maybe you have a small company. Finally, you have something called federated architecture. I think this should be the most ad hoc way of doing business.
What does ad hoc?
Ad hoc meaning temporary. You don't do it like regular basis. So what is federated architecture? It means that whenever I need the data, I never organize myself. I know you have your sales data, I know you have your finance data, you are running your own database. It could be a database, it could be a data warehouse. So when I need, I go to that and get my data. But because I'm not doing it regularly, now you're having your own independent one, you're doing your own independent one. It is almost like the one that I showed you earlier. You have those different sources, and I need to do my data analysis. I just go to the source directly and independent source and get data what I need. Right?
It's more efficient.
Let me explain it. Okay. Less costly for sure, right? Because you are not maintaining their data warehouse and so on. But it can be a situation where you're highly dependent on the source. Plus, every time when you do analysis, you have to do conversion. You have to process, you have to clean. Your data is not ready for analysis. So you remember I used the word ad hoc? Ad hoc meaning that when certainly there is a need that arises now, I don't do it like every month, this analysis. I don't run it. My boss just says that one time we have to do this analysis, so there's no point creating a data warehouse for it. So I collect my data, I do my own processing, cleaning and everything, and then I'll do my analytics. And khalas, then chapter close. Because I don't have to repeat it. So there's no justification of doing warehousing. You understand that? So in such situations, maybe federated databases are used. By the way, federated is from the word federation. Have you heard about this term, federation? Certain countries are following this federation model. In Saudi Arabia, the whole country is one, right? But if you go to, let's say, United States,
Oh.
each state is like an independent, almost like a country, but they have made a kind of a pact.
On laws.
Yes, they have their own laws and everything, but they say
Mhm.
in terms of army and security and all, we will behave like a single country. EU, European Union, right? They were separate countries, but they made a pact like will behave like a single country, right? So federation means they are all independent, but they can decide to work together. So the word is from there. You can see that here you're looking at what? Unconnected relational databases, data marts, data warehouses. Wherever you get that data, you get it from there, and then you have to do your own data mapping, cleaning, and everything, and then you have to do
You mean
your
analysis?
Here, you analysis, but you have to do all your cleaning and mapping and everything by yourself, and then you will be able to get it done.
Do everything manually.
That is the problem. So it is the best way to do it if you're doing it temporarily, like I said, ad hoc.
Yeah.
Once or twice. But if you have to do it like every month, every week, then it becomes like a real pain. So you need to have a data warehouse where all this data cleaning and storing, all of them are happening and you just have to pick the data and do your analytics, okay?
Mm-hmm.
So I think I'm going to stop now, and the rest of the chapter, inshallah, we'll cover next time, okay?
Okay.
Thank you everyone, and inshallah see you next week.